Okay, so in this video we will be going over Physics 2211 Test 1 Problem 3, where we will be answering the question of how far the ball will go, illustrated here, in the x direction before reaching the ground. We're given the height, the angle in which the ball is initially kicked, the initial velocity. Okay, so from what we were given, we can find the initial velocity of y, given here. What we need to find is the final velocity of y, and we know that the initial y is equal to h. Y final is also equal to 0. So these are what we know. We need to find v average of y, which is equal to v, the initial velocity of y, plus the final velocity of y divided by 2. And velocity of average, the average velocity in the y is also given by change in y over change in time, which is further substituted into this, which is equal to negative h over delta t, which is the main focus of why we are using calculating the average velocity in the y is because we're finding delta t, which we would ultimately plug into the average velocity in the x direction, which is equal to delta x over delta t. And now that we know delta t, we can find what the change in x is, which is what the problem is asking for. Okay, so it is important to note that this is a constant force, which is the reason why we can use this formula here to calculate the average velocity. We should also note that there is no force in the x direction, so this would mean that the average velocity in the x direction will be constant. Okay, moving on. We know the momentum principle to be the final momentum equals the initial momentum plus the force in the y times delta t. So from here, we know if we just simply divide by mass, we get the final velocity of y is equal to the initial velocity of y plus the gravity times delta t. We can see that f of y is equal to mg here, so dividing by mass will simply give g, which simplifies the equation. With v velocity and final y, we can now find the average velocity of y, which is simply the initial velocity plus the final velocity divided by 2. The initial velocity is given here with a v sine theta, which we went over earlier, and by calculating and substituting everything in, we find that the average velocity of y is v sine theta minus g delta t over 2. Now continuing on to the second step in our problem solving, and we find that if we set these two equal to each other, we get v sine theta times delta t minus g delta t squared over 2 plus h equals 0. This is by setting equal the two equations for v average of y. From here, we can actually get a very neat quadratic equation which we can ultimately solve for delta t. And using the quadratic formula and substituting in a, b, and c as negative g over 2, b equals v naught sine theta, and c equals h, we find that delta t equals negative v sine theta square root of all of this over 2 minus g over 2. And through further simplification, we arrive at this as our delta t, which is all we need to find the average velocity in the x direction, which is simply delta x over delta t. From here, we see that delta x equals the v average in the x direction times delta t, which would simply give us the change in x is equal to the velocity times cosine theta times delta t, which we calculated from above right here, and we are done.